We're going to learn about different types of fractions and then how we convert between them. And we're going to do this using cake. Here we have our first cake. It's whole and represents the whole number 1. Let's cut it up into pieces and then see what we've got. So now that we've cut up our cake, it's in 8 parts and we can use this to learn. We will be starting with simple fractions and then we will get a little harder from there, but it's all pretty straightforward. Because we had 8 pieces, if we now just have one of them, we now have the fraction 1/8. And if we add 2 more back, we have 3/8, another 2, and it's 5/8, and so on. So as I mentioned, these are called simple fractions, and they are that, very simple. But there are 2 other types of fractions that we're going to learn about. The first is improper fractions, but to do this, we're going to need another plate. So now we have our 8/8, but we also have 3 more, and as a fraction, this is 11/8, and we write it as 11/8, and we have a visual representation using our cakes of what this means. Let's add another 4 pieces, and now we have 15/8, which we represent as 15/8, and again, fractions where your top number, the numerator, is bigger than the bottom number, the denominator, they are called improper fractions. Let's look at the last type we're going to discuss. This third type of fraction is called a mixed fraction, and this is where we have an integer, which means a whole number, that we were representing earlier with our whole cake, and then we have a fraction with it. So here we have 1 and 3/8, which is just like the 11/8 we had before. They represent the same number. It's just a different format. Now we have 1 and 7/8, which is the same as 15/8 that we had before. I'm showing you the same numbers so that you can see that there is a close relationship between improper fractions and mixed fractions, and that they represent the same numbers just in different formats. In fact, we need to be able to convert between them. So let's look at how we do that. So to convert from a mixed fraction to an improper fraction, we multiply our denominator by our whole number, and then we add the result of that to our numerator. That's it. It's a 2-step process, and we have converted from a mixed fraction to an improper fraction. Let's try another example. 2 and 1/5 to an improper fraction. So 2 times 5 equals 10. 10 plus 1 equals 11. So we have 11/5. Now we need to be able to convert in the other direction too. 14/5, let's convert this to a mixed fraction. Again, it's done in 2 steps. First, we see how many times your denominator, your bottom number, can go into your numerator. 5 goes into 14 twice, because 5 times 1 is 5, 5 times 2 is 10. So we leave 2 as our whole number outside the fraction, and that's step 1. Now we have 4 left over, because 14 minus 10 equals 4. So we leave whatever we had left over as our numerator. So 14/5 as a mixed fraction, 2 and 4/5. One more example, 13/4 as a mixed fraction. 13 divided by 4 is 3. We have 1 left over because 4, 8, 12, and we can't quite make it to 13. So 3 is our whole number, and we had 1 remaining, so that is our new numerator. Before we finish, I have one bonus skill for you to learn, and it's about simplification and equivalent fractions. 1/2 is the same as 2/4, so we can say that they're equivalent. And if we just keep following this same pattern, 3/6 and 4/8 are also equivalent to 1/2, and they're equivalent to 2/4 because our numerator is half our denominator. However, fractions like 4/8 are less easy to work with than 1/2, so we simplify our fractions to their simplest form. So just be sure that you pick this up as a habit. But outside of just using it for simplification, we can also find hidden numbers within fractions. So if 2/3 is equal to a over 12, we're able to find a if we know that a over 12 is equivalent to 2 over 3. So if we make our denominator, 3, become 12 by multiplying it by 4, and we do the same to our numerators, we do this because otherwise our fractions would be representing different numbers. So you have, whatever you do to the bottom, you must do to the top. Now we're able to find a. 2 times 4 equals 8, and so a equals 8. Last example, 9 over 15 equals 3 over b. Now to get 9 to become 3, we must divide it by 3. We do the same for our denominator. 15 divided by 3 equals 5, and we can find b.